Welcome to the first optional practice problem in the Programming in Python 3 series. Like I mentioned before, the first half of this video is going to be me reading through the problem and discussing it, and then the second half is going to be me giving the solution in a way that I would. This is going to be completely unedited, and I haven't prepared a solution before this video, so everything is going to be genuine and real. I've split this problem into two parts to give you more practice, but both will be involving implementing some sort of equation or solving a mathematical problem. Math is pretty important when you program, so that's exactly why this practice problem is going to work on math. But the overall topics that it will review are variables, data types, typecasting, gathering user input, and then mathematical operators. The problem for part A says to give a temperature in Fahrenheit and then output that temperature in Celsius and Kelvin. I've given the formulas down here to be able to convert Fahrenheit to Celsius and then Celsius to Kelvin as well. As a bonus for part A, instead of giving a temperature in Fahrenheit, give a temperature in Kelvin and then calculate and output that temperature in both Celsius and Fahrenheit. So you're basically just going to go backwards, and instead of giving Fahrenheit and then getting all the way to Kelvin, you're going to go backwards and reverse those formulas. For part B, let's assume that every planet has a circular orbit around the sun. The Earth is 91,406,000 miles away from the Sun, or 147,100,000 kilometers if you use kilometers. Calculate the distance, or the circumference, that the Earth travels around the Sun each year, and output that result to the console. And then depending on which unit you use, you can either do that in miles or kilometers. It doesn't really matter. Down here, I have the formula for calculating the circumference, and what the circumference is just the perimeter around a circle. For a bonus problem, allow the user to input a planet's distance from the sun. So this can be a real planet or a made-up planet or just any distance in general, but be able to accept any distance in from the user and then calculate that distance that the planet travels around the sun each year and then output it to the console. I highly encourage you to try and solve this before watching my solution. These aren't very difficult problems, especially if you don't do the bonus problems, but they are here to help, so I highly encourage you try these before you watch my solution. This is going to be my solution to part A of practice problem 1. Just a reminder that I do not have a solution planned for this, so this is going to be me going at it for the first time live. So let's go ahead and get started. I would assume that this problem is relatively straightforward, but you should also make note that there are multiple ways to do this, I'm sure. But for the sake of this problem, like I mentioned, most of you are probably going to have roughly the same kind of work going on if you choose to do this. So if we look back at problem A, you'll see that we have to give a temperature in Fahrenheit and then output it into Celsius and Kelvin. And then as a bonus, you basically do the opposite. You give a temperature in Kelvin, then you calculate in Celsius and Fahrenheit and output that. I have given you the formulas here for calculating Celsius and Kelvin. So let's go ahead and implement the base problem, which is relatively simple. You just, essentially plug in this formula into the code and then you run it. So first things first, let's go ahead and get the input from the user. I'm going to call this variable f to signify like Fahrenheit. I'm going to say enter the temperature in Fahrenheit, and then that will gather the input from the user. So that's the first step done. So then to calculate Celsius, let's go ahead and look back at the formula. You'll see it's Fahrenheit minus 32 times 5/9. So I'll go wrap this in parentheses, Fahrenheit minus 32 times, and then I'm going to wrap this in parentheses too because it's a constant. It's not another number you're dividing. So I just want to make sure that the interpreter knows that I want it to explicitly calculate this and then make sure it's multiplying by 5/9 and not multiplying by 5 and then dividing by 9 and so on. So that should be the Celsius, and then if we want to calculate Kelvin, you just take Celsius, and then I believe you add, 217.15. So 217, oops, 218, whoopsies, 217.15, and that should take care of all of our calculations. Let's go ahead and print these out to the console here. So if I print like temperature in Celsius, and then I'm going to separate these with a comma and pass in C, and I'm going to copy this line, paste it, put the K in here, and then just change this to Kelvin. And then that should be our first part to the problem. So if we run it, I'm going to pass it like, we'll pass it 32 because we know that 32 degrees Fahrenheit is 0 degrees Celsius, or you might know that. So if we get 0.0, then that means that we have done perfectly, and then we should get an even 217.15. So that just works out perfectly. So we know we did that. Let's go ahead and get to the bonus problem. So I'm going to mark this with bonus here and then just separate this. Oops. So I'm going to comment all of this out. This is just our previous work. And we will take a look at the bonus problem. So the bonus problem says to give a temperature in Kelvin and then calculate and output that in Celsius and Fahrenheit. So start the same way we did before. Take an input from the user and we'll say enter the temperature in Kelvin. So there's the input. We have our Kelvin, so that's that. And then calculate Celsius, we just basically want to do the complete opposite that we do to calculate Kelvin. So we want to take our Kelvin and subtract 217.15. So that's relatively easy. Now, if we want to check our work to make sure that we did that, let's just go ahead and steal this line up here. Paste that, remove the comment. And then let's go ahead and run this. So if we just give it, well, let's give it 217.15, we should get 0.0. Perfect. Now, let's go ahead and clear that and then do the harder part of the bonus problem here. Let's go ahead and calculate Fahrenheit from Celsius. So we basically want to go backwards on our formula. So if we do that, it should be like Fahrenheit, you want to take your Celsius, I would say, and then multiply that by 5/9 and actually get rid of, or no, we do want to keep these parentheses here. And then I think add 32 would be like the opposite of that formula there. And then let's go ahead and print that. Again, remove the comment, change it to Fahrenheit, and then we should be good. Hopefully. Let's see if I did this right. Cool. So let's give it just a test case again. So we'll do 217 for the Kelvin. That should give us 0 and 32. Perfect. So if your solution gave out these outputs, I would consider it pretty successful. This was just the way that I chose to implement this problem, and I'll go ahead and uncomment these here just so you can see what my code looks like with my syntax highlighting. But yeah, so the first part, we just gathered the input, did our calculations, and then did the output. And this was supposed to be more of a warm-up than like a serious problem, but the bonus problem was the one that you might have had to put some more thought in. If you had to Google anything, I wouldn't have blamed you because your resources are always going to be out there. So this was my solution for part A. This is going to be my solution for part B of practice problem 1. This problem says that you should be able to get the distance of a planet, or in this case, Earth, for the first part, and then calculate the distance that it travels around the sun. So normally planetary orbits are elliptical. Very rarely are they perfectly circular, if there even are circular orbits out there. But for this problem, let's just assume that all planets travel in a perfect circle around the sun. So if we want to find the distance that the Earth travels around the sun, we need to calculate the circumference, because the circumference is just the perimeter around a circle. So the formula for that down here is 2 pi r. You might remember that from school, or you might get that confused with the area of a circle. Either way, I have it here. So if we have the distance that the Earth is away from the sun, I have it in miles and kilometers for you. I'm going to use miles for this problem, but feel free to implement this in whichever unit that you use. So for part A, I'm actually going to create a constant here called pi because we need to know what, so I'll do like 3.14159 just to be a little more precise, but I could just leave it at 3.14 and that's totally fine. So I'm going to create this constant here because pi never changes, and we did talk about constants in the video on variables and data types. So I'm going to define our first constant pi, and then for the first problem, it says to calculate the distance that the Earth travels around the sun. So we have the amount that Earth travels around the sun, or we actually have the distance that the Earth is from the sun. So I'm going to go ahead and paste that in here, and I'll even do the underscore thing just so we know. And I'm going to call this like distance, or we'll say like Earth distance. Because this is actually a constant too, right? This never changes. If we're assuming that this is a circular orbit, then this is never going to change. It's always going to be 91,406,000 miles away. And I'll leave like a note here. I'll make it like this is miles just so people know. So let's go ahead and get to calculating. So basically we'll call this like dist, and this is just going to be the circumference of a circle. So you want to do pi times the diameter or 2 times pi times r, and in this case the radius is as far as it is from Earth because the sun is going to be in the center of this circular orbit here. So that'll be the radius, so the distance is just half of the diameter. So we'll do 2, multiply that by pi, and since this is a, and then the radius too. So since this is a just multiplication, it doesn't matter which order you do it. You don't have to force parentheses around any of this to calculate any of it first because it's all going to get calculated in the same, by the end. So let's go ahead and print this, and this is a relatively easier problem. So we'll say like the Earth travels, or we'll say the Earth travels, and then we'll just do that. So we'll know it's in miles, right? Or we can actually pass the distance and then pass another comma and then do miles. And this will know that it'll separate each value by a comma and go. So let's go ahead and run this. And then you'll see that the Earth travels, and it is formatted a little weird, and it did force it into a decimal because pi is a decimal. But let's go ahead and see if we can parse this here because it is a little hard to read. So it looks like it's 574,029,680 miles. So that's how much it travels every year. So I don't know if that's exactly correct. I haven't looked it up, but I'm going to assume for this case that it probably is because it's only calculating the circumference. So that was the first part of the problem. If you chose to do the bonus problem, I'm going to solve this right now, and it's going to be relatively the same. We can actually keep our constants, but just comment this out, and we don't need to keep the Earth distance because we're not going to be using that anymore, but I will keep pi because pi is a constant that is going to be there throughout the entire problem, right? So for this problem, let's go ahead and do we'll do dist again, but we're this time going to do float. We want to cast it as a float just in case it's not exactly whole. And then we'll say like enter a planets, if I could type planets distance from the sun. Or we'll say from the star, because maybe this is in a different galaxy and it's not going to be the sun, right? So now we have the distance. Now let's just calculate, we'll say like dist traveled, maybe. That'll make it a little more clear. Traveled, and then this is just going to be exactly the same. You do 2 times pi times, and then the radius, which is just the dist. And then we will just copy this line, go here, and we'll format this to make it a little more. So we'll say the planet travels blank miles. So now if we enter the same amount that we had for Earth, we should get the exact same result, and then that would indicate to me that this problem was successfully solved. So let's go ahead and it says it cannot convert type. Oh, I forgot to do the input. Oops. That is, there we go. Okay. That makes a lot of sense. Let's clear that and try that again. So enter a planet's distance from the star. So we'll just grab the Earth distance. So 91,406,000. And that should be, oh, oops. Passed in the wrong, man, I'm just messing up. If you caught that, good job. Otherwise, oh well, not a big deal. Let's try this one more time, and this time it should be it. So 106,000 or 91,406,000. And it looks like if we uncomment this, let's go ahead and see if we got this right. So that looks right from what I remember. So yeah, and then we'll do 91,406,000. And good, we got the exact same number back. So there you go, you have successfully calculated the distance that the Earth travels around the sun each year, or the distance that a random planet travels around the sun or a star each year. I hope you enjoyed this optional practice problem, and I hope that it helped you practice everything that you've learned with Python so far. We're going to get into more fundamental concepts of programming and computer science in these next few videos, and then you will have your next optional practice problem.